Hello, everybody. I'm Pete Freitag, and today we're going to be talking about tackling ColdFusion security. So first, just a little bit about me. Most of you probably would recognize me as the guy that wrote all the lockdown guides for ColdFusion. So starting ColdFusion 9 all the way up through ColdFusion 2021. My company is called Foundeo Inc., which I do a bunch of things there, including consulting, code reviews, server reviews, and development work, as well as a number of products, including FuseGuard, which is a web application firewall for ColdFusion, HackMyCF, which is a ColdFusion server security scanner, and the latest product I have is called Fixinator, which is a code security scanner for ColdFusion code. So everything I do pretty much is focused on ColdFusion and security for the most part as well. You can find my blog and Twitter there as well. And I'll post these slides to my blog at some point. And I've been using ColdFusion all the way back since the late 90s. So been quite a few years now. So let's take a look. How is 2021 going in terms of security? So pretty much the same as 2020 and the year before that. It's just kind of seems like it's constantly escalating, and we're just getting a barrage of different types of attacks. Large companies are having issues, small companies are having issues. It doesn't really matter what type of company you are, or organization you are, nobody's really immune to this problem. So some takeaways: we're all impacted by it. Even the smartest developers will still write code that has security vulnerabilities in it. So we know that there's no such thing as this absolute security or perfect security. So I think sometimes as developers, we try to chase that idea that we can have things that are perfect. But as you all know, when you write code, there's bound to be bugs in it. So if you think you could write code without ever having a bug in it, that's kind of the same idea as thinking that you're never going to have a security issue within your code. It's not a likely thing. So with all that, it might be kind of tempting to just throw your hands up in the air and ignore it. We certainly can't ignore it. And so it's probably a good time to take some action on it, maybe if you have been ignoring it. So we know that security breaches are skyrocketing. We know that more vulnerabilities are being discovered in software and hardware. So actually the number of CVEs, which are like the little identifier number that they give to a vulnerability, has tripled the amount of CVEs that they issued in 2015 versus 2020. So it's difficult to stay on top of something like that because they're constantly coming at you with fixes, and it's a difficult problem, and it doesn't seem like it's getting easier. So security is hard, and we as humans are constantly failing. So one thing we can do is avoid being an easy target. So some of the tactics we're going to go through here in this presentation should hopefully help you from being the easy target, and at least some small steps you can take to start improving the security. So like I said, I think it's a good time to start focusing on improving the security. It's almost the new year, 2022. Make it a goal for your year to improve the security of your web applications. All right, but you don't have to do it solely alone. There's things you can use, such as tools and processes that can really help you be more productive in trying to achieve that goal without putting everything on your shoulders. So things like CI/CD, different security tools, testing, and then getting additional help from your colleagues, your boss, your management, security team, if you have one. And so that's an important thing. I think sometimes people overlook as well is that a lot of times management, they want to improve the security of the applications, but they might not know what needs to be done, or that there is even weaknesses at all within your applications. So if you go to your management and say, I think we need to spend some time improving the security of our applications, they might have had the assumption that they were already secure. So I think it's good to set that expectation up as well, is that this is something you constantly need to be working on. So we're going to look through 10 different places within your code that, or 10 different ways where we can improve security in your ColdFusion applications. The first one, let's delete some old code. So you've seen this before, where you have index_2.cfm, index.old.cfm, all these different maybe old copies of codes that you're keeping around for preservation purposes. I'm not really sure why we do it, but we tend to like to keep these little things around in case we need them. So the solution to that is version control. When you have version control set up, all of your old code is still kept a copy of somewhere, and you could go back and look at it if you really wanted to someday. So when you have version control, you can go ahead and delete all these types of files that look like this, because you don't need them anymore. But what happens is a lot of times these old files might have security holes in it or weaknesses in it because they were maybe written 20 years ago. So it's a good idea to kind of like clean up and get rid of those things. And also just, it helps you do your job easier, because the less files you have to maintain and deal with, the easier your job's going to be. So actually going through and deleting code, figuring out like, hey, you know what, this code here was for a conference that took place in 2005. We don't necessarily need that code anymore, so we can delete that whole folder. Maybe, maybe we've got a poll up here somewhere that was written in 2007, and we can get rid of that thing. So if you can go through your web applications and see, there's maybe some parts of it that aren't really being used anymore, we can clean that up, and that can potentially reduce our attack surface as well. So like I said, version control will get back any copies of it that you might need if you did make a mistake in deleting something. So don't worry about it. So there's a lot of fads that we see in software development, but version control is definitely not one of them. It's been around a long time, and it's not going anywhere. It's definitely something that if you haven't given a chance yet, you should really spend some time. Maybe if you're in 2022 starting the year and your code is not under version control, maybe that's a good goal to start with, is getting it into version control to start off the new year. So some ways you could find old files that maybe haven't been modified in a long time would be using the find command on Linux or Mac. You can run through and it will compare the file timestamps to see, do we have code that's really old. You can do the same on Windows. It's a little bit more complicated, but same result. On certain versions of Linux, if you have a Linux server, you might even be able to figure out the last time a file was accessed, which would be kind of handy to say, you know what, this file hasn't even been accessed in a year. We could probably don't need it anymore. Okay, so the next kind of big thing that we can do to improve security is to delegate some of the portions of our applications that are maybe security sensitive over to services or interfaces that are built with a high level of security. So one good example of that would be payment processing. So if you have the option of maybe delegating the payment portion over to a different provider for that chunk of the transaction where the user enters their credit card number and things like that. If you can offload that risk, then that would improve, but that would take away a lot of security burden on your application. So it might even lessen if you have to deal with PCI compliance requirements. It might even lessen that type of thing. So another area where is a good potential candidate to delegate away from would be your authentication. So if it's an enterprise application, then you might be able to leverage some sort of single sign-on solution like Active Directory, LDAP. We'll talk a little bit more about that kind of thing later on. If it's a consumer-facing application, maybe you can leverage Apple sign-in, Facebook sign-ins, Twitter sign-ins, etc. So your authentication, if possible, delete your authentication code and delegate that to a different provider. So one way you can do that is actually using a protocol called Saml. Another way might be OAuth, whereas it makes the amount of code that you use to do authentication very small. What's nice about it is you no longer have to store passwords. So that also means nobody's going to be calling you up to reset passwords or things like that. So your users will notice it and they will like it because they don't need to keep a separate password just for your application. They'll be able to just sign in one place. So it can be both a security improvement as well as a user experience improvement. So how does Saml work? The user visits the application and then your application redirects to the identity provider. And from there, the identity provider provides the login page for the user, and the user would log in. They might do two-factor authentication, all that kind of stuff would happen on their end. And then once the identity provider says, okay, yep, this is a good valid login, they redirect back to your application. And they also provide some sort of like secret signatures and things like that that you can verify to ensure that it was authentic. And from there, you can log in, have the user marked as logged in, as well as what the identity of the user is, etc. So ColdFusion can act as that SP portion of this with the ColdFusion 2021 adds some functionality that makes that a little bit easier. The identity provider might be like something like Active Directory, Shibboleth, OneLogin, Okta. And so what it looks like from a ColdFusion implementation is there's a few different functions that you can use, and as well as some configuration that you'd need to do within ColdFusion Administrator or within your application CFC file. If you're running an older version of ColdFusion, or you want to maybe not have it tied to that implementation, there's other ways to do it, such as the Java SAML library or OpenSAML. You could, I guess, roll your own SAML implementation, but again, that kind of defeats the purpose of this idea of delegating our critical security functions to expert libraries and APIs that can handle it and are designed to handle that sort of thing. So you can also, there's even web server extensions that might be able to act as a facade. So you might be able to have like an IIS plugin that might handle that part of it for you, and then it'll just pass the authenticated user through via a header to your application. Okay, so secrets, key management. So you definitely want to avoid using your source code to store the secrets in, especially if you're on version control, because then that secret ends up getting put in different places. And so it's really not a place where you want to keep things like passwords, API keys, or things like that. A good approach to this is to using a secret or a key management API. So there's a bunch of cloud-based ones that you could leverage. AWS has a bunch of ways you could do this, from KMS, Secrets Manager, to the EC2 parameter store. Azure has Key Vault. If you're looking for an on-premise solution, HashiCorp Vault is a good solution for that sort of thing. So these are built by world-class security experts. So it's a good idea to delegate these sort of sensitive operations to those. All right, so our next topic is secure configuration. So if we take this idea that we can assume that stuff will be breached at some point. It kind of changes a little bit how you go about setting things up. So it makes you want to follow the principle of least privilege, which says that a user should only have permission to do the tasks that they would be allowed to do and nothing more. So kind of like you're on a need to know basis type of thing. And so if you're following that sort of thing, it helps minimize the impact if you did have a breach. Like let's just think about this. If we've got ColdFusion running as the administrator root user and our ColdFusion server is breached, well then the breach of that might allow the attacker to have administrator or root access to the server. But let's say we have locked that down to so the user is running as ColdFusion running as a specific user. We might minimize the impact of what the attacker was actually able to do. So maybe they could still get into the database, but that was kind of the limit of it. And maybe we set up the database so that it was a read-only database, so they really actually could just run additional queries on it, but it didn't really, it made the impact of the breach very minimal. So go through security best practices for configuration, such as the ColdFusion lockdown guides. There's STIGs if you're doing government or military stuff, as well as the CIS benchmark guides. Just gonna pop in, let's see here. I'm just going to pop in because we have a few questions. I'll try and answer those real quick. So recommendations for version control systems that work well with web applications. They all work well. I tend to like Git is probably the most popular Git-based version controls. So things like GitHub or GitLab or Bitbucket are all popular ones, and they all have a way where you can get started for free if you wanted to. So any of those three would probably be good starting points: GitHub, GitLab, or Bitbucket. And then the other question is, could Saml be used for limited concurrent sessions? I'm not sure what you mean by that. Maybe at the end we can discuss that one a little bit more. Okay, so thinking some more about locking down ColdFusion, what user is Java running as? So we talked about this a little bit. If it's running as root, then it's going to have a lot more permission, and if there is a breach. Another thing would be, does the server need full access to the web root, or does it maybe only need write access to like a single folder or a couple folders in the application? So if we don't need to be writing files all over the place, we can limit the scope of what it can do. And that really improves the security, especially if there is any sort of breach. Having a good secure configuration can really limit what the attacker could do. When it comes to the database, again, let's make sure we limit it to the minimum amount of permissions that's needed for your application to run. So if your application doesn't need to drop tables from the database, then why does it have permission to do that? So if you restrict those kinds of things, then it limits what an attacker could do if you're breached. All right, so let's take a look now at there's all sorts of different types of injection attacks. So I kind of put these, we're going to talk about a few different ones within this topic here. The first one we'll talk about is called a PDF injection. So this is kind of similar to cross-site scripting, but it's a little bit more impactful because it runs server-side, the actual code that is executed. So let's assume here we're generating a PDF. Here I'm using CF document, but it could be, you'd have potentially the same issue with CF HTML to PDF. And the example on the left here is vulnerable to this type of attack, where I'm just outputting hello url.name. On the right, I fixed it with Encode for HTML because it's not going to allow any sort of HTML to be executed. So it's very similar to cross-site scripting, but what this can allow is that when you think about it, when the HTML is rendered to generate the PDF document, where does that rendering happen? happens on your server. So anything it's doing, it's going to have to execute on your server. So for example, let's say that url.name, if you paste in a image tag for the name, it's actually going to perform that GET request to try and fetch that image from your server. So let's say there was some sort of internal service that an attacker wanted to hit, they could make that request from within your service, or maybe they could do like an iframe or something like that, even potentially to load in different data. It's making that internal request from within your server. So that's called a server-side request forgery attack. But there's different things that could potentially happen within this. So you want to be careful about what the variables are that you're outputting within a PDF. So I can show you a quick example of this in my application. The Bank of Insecurity. And so what this application is, it's basically full of security holes. I'll log in. All right, so now I'm going to go to my bank statement here. Okay, so you'll notice here that it's got a bunch of variables here in the URL. One of them is a month that happens to be output right here. So if I change this month to like an image, so I'm changing it to, right, so I just changed that so that it would actually fetch an image for me. So that's making that HTTP request from the server to that resource. And so if there's any sort of IP restrictions or things like that, that might end up, creating some sort of bypass or accessing some sort of information that wasn't supposed to be happening. Alrighty. So let's continue here. Okay, so the next one we're gonna look at is called something I call scope injection. It's kind of just like it's a ColdFusion specific vulnerability. And so it's just kind of the name I gave it. I don't know if it's the best name for it, but the idea here is that let's say it takes advantage of the scope cascading features of ColdFusion. So what that means is that if I output a variable without any sort of scope on a page, ColdFusion is going to look in all different scopes. It's going to look in the variable scope. It's going to look in the URL scope. It's going to look at the form scope. It's going to look in the cookie scope to see if that variable is defined. And so that's kind of a handy feature, but it can also be not the greatest in terms of security. So let's take a look at this. It's better to just see this one. So this is kind of like the bank user page, right? So what I'm going to do though is I'm going to log out here, and I'm going to go back to this page. And what I'm doing here is I'm passing into the URL session.userid equals 2, session.isLoggedIn equals 1. Session.isAdmin equals 1, and session.username equals hacker. And you can see here that now I'm actually outputting member ID 2's information and their balance is and everything else because the session variable isn't defined when I logged out. If the session variable isn't defined, then ColdFusion is going to go looking in other scopes. So it's actually matching url.session.userid, but my application code thinks that that's an actual session variable. So that's where this type of vulnerability can come into play. So how do we get around that? Well, we want to make sure that our session variables are always defined. So they should be initialized to a value. So when on session start, there should be something that sets session.userid equals 0 or something like that, so that it can't be taken advantage of in this way. You can also use, so is defined is not great because that will allow for the scope injection. But if I use something like struct key exists, or if I did like session.keyExist user ID and put that in an if statement, then that would work a whole lot better in terms of preventing this. And then there's also a setting you can use in Applications CFC called search implicit scopes. If you set that to false, it will prevent that scope cascading from working, but probably might also prevent your application from working as well if you weren't careful about how you scoped all your variables. So that is a good solution, but it's going to require some time to actually make sure. You're going to have to test your entire application if you do make that kind of change. So if you're real good about scoping every variable, then you might just be able to flip that switch and it'll be good. Okay, so there's all sorts of other types of injection attacks that we don't have time to talk about today, but there's things like XML Entity Injection, which is something you want to be careful about if you're parsing XML. There's XPath Injection if you're using like the XML search function. There's LDAP Injection if you're using the CF LDAP tag. There's command injection if you're doing something like CF execute. So all different types of things. OWASP is a good resource, owasp.org. Especially their cheat sheet series has a lot of good information on these types of attacks, explaining what they are, what you should do to prevent them. And a lot of these attacks we're talking about, really the only one that's been specific to ColdFusion so far is the scope injection one, but pretty much everything else is not specific to ColdFusion. I'm just showing you kind of how that pertains to ColdFusion, but these are types of issues that every single web application developer has to think about and worry about. Okay, next section, cross-site scripting. I'm not going to spend tons of time talking about this. What I'll do is I'll just show a quick demo of it. Essentially, if you're just allowing variables to be output without making sure they're encoded to escape things like the less than character so that they're not turned into tags, then it can allow a script to run on the page. So let's take a quick look at this. All right. So let's see, I believe what we're using here is the search feature here. And we see when we search, it says, sorry, your search did not turn up anything. But we can take advantage of that. And for example, this here is just showing that it's going to actually run the JavaScript. So when you see like alert 1, that's just somebody testing to see, does JavaScript actually work? And if you can do an alert 1, then you can pretty much do anything, including something like this, which this looks a lot like the login form for the site, right? So if you were to send a user an email and say, hey, please go to the bank and check out this page, important information about your account, they're going to go to this bank. And even if they have good security knowledge, they're going to look at the address bar and it's going to be an HTTPS and it's actually going to be the bank that they're thinking. And they're going to go ahead and log in with their bank credentials. They're probably not going to notice this stuff because even on a lot of browsers and mobile devices, they're hiding all of that, the query string information from the URL these days. So they're not even going to see all this, even if most people don't understand that, except for developers like you. So, but when you actually log in, this form action is going to a different site. Yeah, so if I click this, it's not the real login form. We're finding out here. So that's how you can see cross-site scripting can be very dangerous. It's kind of a tedious problem. Wish I could give you better news about it. It's kind of a pain to deal with. You got to be careful when you're outputting variables. If they're not trusted variables, then they need to be encoded. You can use the encode for HTML. There's other encoder functions depending on where the variable is output. So depending on if you're outputting a variable within the attribute of a HTML tag, then you use encode for HTML attribute. If you're outputting a variable inside JavaScript, like in a script block or an onClick, then you'd use Encode for JavaScript, etc. There is a handy feature that was added a few versions back. CF output has an encode for attribute. So you can say encode for equals HTML, and then it will automatically encode all the variables within that CF output block for you. So when there might be some cases where, let's say you got a CMS or something like that, where you're actually do allow certain HTML content through. I mean, if you can avoid it, try and avoid that scenario. But if you can't avoid it, then there's functions like isSafeHTML or getSafeHTML. And those basically try to apply all sorts of rules to say, this looks pretty good to me, but I don't think you can treat that as that this is 100% safe unless you really tweak the policy of that really well. So it's kind of a tricky scenario. So, but it's like probably like a 99.9% safe in most cases, but there could be ways around it if you're not careful about how those policies are crafted. Finally, last bullet there is content security policy. So this is a browser feature that gets turned on when your server sends back an HTTP response header called content-security-policy. And what this is really actually a cool feature that's worth looking into a little bit if you're not familiar with it. And what that does is it will turn on kind of like a sandbox for what's allowed to execute on the page. So I could tell with my content security policy, for example, that only allow images to be loaded from self, which means the same domain as this page that it's on. And then if somebody tried to load an image from an external domain, the browser would just block it. And so you can do the same thing with scripts. You can say only allow scripts from self. So that's really a cool feature that's worth checking out that can help really mitigate cross-site scripting on the browsers that support it. But again, it's probably not like a always perfect solution, but it's a pretty good one. So this can be a time-consuming area of a very large legacy application. So a question in the chat was, instead of encode for HTML, is there something we could do in application CFC that could apply to all variables? Not really. You could take what you could do is you could do something like on request start or on request. You could wrap the on request and then take a look at the content that's going to be returned back to the user. And then you could run your isSafeHTML against that to see if it looks safe. But that's probably the best you could do, I think, something like that. There's almost never my answer to any cross-site scripting question. It's almost always like with a 99% disclaimer, because cross-site scripting relies a lot of the exploits early on in cross-site scripting were basically exploiting bugs in the browser itself. So it's like, how can I say for sure that there isn't a bug in some browser that somebody might be using that would be vulnerable to it? You can't really say ever for 100% sure when it comes to that sort of thing. All right. I think also somebody was asking for the URL for the application for the example application was it's on github.com/foundeo/cfml-security-training. There'll be a link to it at the end, I believe. Okay, so another area of your application that's going to have a lot of potential issues in it is authentication and authorization. We already talked a bit about how you could possibly delegate this to an identity provider, and then you won't have to worry about all the things we'll talk about next. So you can kind of plug your ears and for a minute here if you'd like, and listen to peaceful music for a second. And otherwise, the things you might need to consider if you do have authentication code is your password storage. How are you storing the password? You'll want to use an adaptive one-way function. And So things like bcrypt, scrypt, password-based key derivation function, PBKDF2, are all good potential choices. I'm not going to comment on which one's the best. I think it's kind of a debatable topic, but those are all kind of considered to be good possible solutions. There might be other ones as well. But you definitely, like the other end of the spectrum is you definitely don't want to have the plain text password stored in the database itself. Some other things you need to be thinking about when you have authentication is something called credential stuffing attacks. So these are happening more and more as more and more databases full of email addresses, usernames, and corresponding passwords are being obtained by hackers through their various breaches that they're doing. They're able to then take those lists of possible valid emails and passwords, and then they'll just kind of constantly try and log in as all these different users and see if they get one that works. So you have to be ready for that sort of thing with some sort of rate limiting by IP address or by user, things like that, if you can really slow down the rate that they could possibly try this, it makes it so it's not really a practical attack in most cases. Password reset flows are often kind of like when you're writing your authentication code, you're sitting down there, the first thing you write, probably not the password reset. You're probably doing a lot of your thinking about the actual authentication part. And then you're like, oh yeah, we need to do password reset. And so sometimes that part of it isn't implemented as well as the actual authentication part in a lot of applications. So the actual password reset code, if you're going to generate a code, you don't want to store that code in plain text in the database because that's very similar to just storing a password in plain text in the database. So you need to also like hash those with a one-way function as well. And then there's thinking about things like two-factor authentication, timing attacks, all things we don't have time to get more in-depth into, but things to consider. Authorization. So does this user have permission to perform an action? So most common problem here might be that, or most prevalent, is that the developer simply forgot to do the authorization check. So like we'll go back to our application here. And we go to my account. Actually, I don't even need to log in because the developer is that bad. So if I go to the statement.cfm now, and I just pass in an ID1, now I'm passing in ID2, now I'm getting Dave's statement, ID3, and now I'm getting Mary's statement. So we're getting, this is called the insecure direct object reference, right? We're just going right to an object and we're getting it back. So the developer didn't check to make sure that the authenticated user is authorized to view this data, so that they're missing that check. These types of things are hard to detect with automated tools, so they're really something that you could actually check by writing your own checks within your application tests. So if you have integration tests, you can actually make requests to say, like, make sure that this user can't access that thing, etc. So a lot more information on this sort of stuff in my security training course, which is like a full day course I do, as well as OWASP authentication cheat sheet, and their authorization cheat sheet has a lot of good things that you can run through. We're just kind of touching the tip of the iceberg here on some of this stuff. All right, so next up, remote code execution. So the evaluate function is one place where remote code execution can take place. So anything you pass into this function as a variable can potentially be executed as CFML code. So if I were to pass in something else into that URL.day, it would actually execute that as code on my server. So let's see, I don't think we have time for examples of some of these right now. But this is essentially how you'd fix it. So we would take the variables, in this case, whatever scope the variable is in this case, it's the variable scope. And we just have to use the bracket notation here instead of using the evaluate, and we can get that dynamic variable that way. So search your code for evaluate. In most cases, you don't need to use evaluate. It's super slow and it has security issues. So basically a good rule is to like say we don't allow use evaluate in our code, and try to remove all calls of evaluate from your code. Also look at precision evaluate. Okay. Any other functions evaluate dynamically? Yep. The IIF function, inline if function, is another one. The second and third arguments there are evaluated dynamically. So those would be, in this case, if I pass something into the URL.name variable, I could actually pass in like some pound symbols and have it evaluated dynamically there. So to fix this inline if, we could use if we want to keep it as like a one-liner, we could use the ternary operator, which is the question. You do the condition, question mark, the value of true, in this case friend, otherwise colon, the value of false. Elvis operator in this case would work as well. All right, so SQL injection. This is another classical security problem. Unfortunately, they still are getting exploited today. But it's kind of something I feel like I have to cover because still can see them out there. So the idea here is that any variable that's going into your SQL that's not passed in as a parameter has the potential for SQL injection. So in this case, if we were to pass in news.cfm ID equals 0 semicolon delete from news, we would delete all the news stories from the table. To fix that, we can use CF query param. So it's as simple as that. And script based, if we're using query execute, then you still can have the same problem. You don't want to use variables like that. You can use a colon and then pass in the variables into a struct. Okay, so don't really have time for that. Find the example of this, but essentially would allow you to execute the code. Okay, so path traversal is another issue here. Is that you could include a file based on the URL here. So one way around this is to really try and avoid having these types of variables in a CF include. You don't want to have a CF include that's taking in inputs from other places. And so that could cause a file to be included and then it gets executed as CFML by default. So there is a setting, this.compile.ext for include, that you probably want to set to something like CFM only. So that would only execute a CFM file that gets included, but not like if there was a path traversal, somebody included a log file, they could potentially have something injected in the log that then gets executed. Okay, so file uploads, another very important one. 3 core rules. Never trust the MIME type. So that's like the image/JPEG. That shouldn't be your only validation point on this. There is a strict attribute to CF file. It's good, but it's still not perfect. So we don't want to trust that fully. What's better actually than passing the MIME type is passing file extensions into the accept attribute. And then it will make sure that the uploaded file is only of an extension .png or .jpeg, for example. And what's even better, if you look at the bottom example there, is that we're actually specifying the destination file path fully, and we're also specifying the file extension right within the destination so that it's known to be that type. Another important thing, make sure the upload destination is outside of the web root. If you need to move it into the web root at some point, you do that only once you've performed all your checks on it, but you want to make sure that that's like your last step will be moving into the web root. So if possible, use your web server to enforce some additional rules on any folder that might contain uploaded files. So it shouldn't allow CFM files to be executed, for example. All right. So there's a new setting called blocked ext for file upload. You could set that to a star if your application doesn't allow uploads at all. Otherwise, you could create a big list of them. Alrighty, so file access issues, basically you're just going to want to search through your code for all the tags and functions that might access files and then review the paths of those to see. And finally here, unpatched known vulnerabilities. So make sure you've applied your patches. There's all sorts of different vulnerabilities that can occur because you haven't been patched. That's going to make the impact of a breach a whole lot more impactful or easier to be breached. HackMyCF is a tool I have that can help you keep your versions up to date. Next, so known vulnerabilities within your code. It's nearly 60% of breaches due to unpatched vulnerabilities, according to a survey from ServiceNow. So looking at something like the Equifax breach, which was a bunch of years ago, back in 2017, they had a vulnerable Java library. What they found, though, was in 2018, as many as 10,000 organizations, including 57% of the global 100, had downloaded the vulnerable version of Apache Struts after this very well-known breach took place. So some tools for that: Fixinator, OWASP dependency check, retire.js, npm audit, all work for different portions of your code. Some are better for JavaScript, some are better for CFML. So we can see that this is just like the current rate of vulnerabilities. It's constantly going up. So you do need to have some sort of tools going on that are helping you find these things within your applications, because when there's currently about an average of 50 per day and 1,500 per month vulnerabilities published, it's almost impossible to stay on top of this by yourself. So you got to use something like continuous security. You take advantage of your version control. You connect a CI platform. And then every time you commit code, something automatically runs to scan your code looking for security issues. And this is all it takes is about 11 lines of code that you put into your CI, and then it would output a result like this saying, hey, we found these different issues, security issues within your application. So this is example output from Fixinator. So, and the idea here is that we're going to shift left, meaning we're going to let the developer find these issues quickly and fix them right as soon as they commit them. So a whole lot more effective. So here's some resources for continuous integration, CI. It's really a cool feature that you should think about getting into with your application once you've gotten it into version control. Next step is get CI, having tools run on automatically. Some more things. Again, I'll post these slides. So a lot of these are just links and stuff to different resources. And I would take some questions. All right, let's see. Use your own custom tags that limit XSS. Okay, so yeah, somebody was just saying they've created some of their own solutions for, trying to limit XSS, and I think that tends to be a handy thing to have some sort of function libraries within your code that you can leverage to take care of that. Is anyone using IDP for authentication that provides 2FA? I think most of them would provide 2FA. Okay. And I will stick around if there's, I know the feed's probably going to be cut here in a second, but I will stick around in the chat and answer any further questions that might come up. So I'll just say thank you, everybody.